Welcome to lesson 4.1. Today we're going to be graphing quadratic functions. Take a minute, pause the video, get these terms written down before moving on. First term is quadratic function. That's where a function with the highest exponent is 2. The quadratic term is the term of the function where the variable has an exponent of 2. The linear term is the term where the variable has an exponent of 1. And the constant term is the term that does not have a variable with it. A parabola is the graph of the quadratic function. The axis of symmetry is the line through the graph of the parabola that divides the graph into two congruent halves. The vertex is the point at where the axis of symmetry intersects the parabola. A maximum value is the y-coordinate of the vertex at the highest point of a graph, and the minimum value is the y-coordinate of the vertex at the lowest point of the graph. So if we are given an equation, y is equal to ax squared plus bx plus c, where a is not equal to 0. If we are asked to find the y-intercept, that is at c, so that's right here. If we are asked to find the axis of symmetry, we take b and a, and we use this formula, negative b over 2a. Same thing if we're asked to find the x-coordinate of the vertex, it's the same thing as the axis of symmetry. So the x-coordinate and the axis of symmetry are the exact same thing. So our first example, we've got f of x is equal to x squared plus 4x minus 3. So if you were ever given an equation where the variable does not have a number in front of it, like this x squared here, put a 1. So that makes it a little bit easier for us. So the first thing we're going to do is we're going to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So the y-intercept again is at c. Okay, right here we have a negative 3 because it's minus 3. That is our y-intercept. The axis of symmetry, okay, we take b, which is 4, and a, which is 1, and we do negative b over 2a. Well, b is 4, so I've got negative 4. A is 1, so on the bottom I have 2 times 1. 2 times 1 is 2, so I have negative 4 over 2. If I divide that out, I get my axis of symmetry is at negative 2. And then my x-coordinate of my vertex, that's just the same thing. So now we're going to make a table of values that includes my vertex. Now, we usually say that they need 5 points to make a parabola. So the x-coordinate of my vertex, that's going to go in the middle, so that goes negative 2. So what I need to do is I need to pick 2 numbers that are bigger and 2 numbers that are smaller. And I need to plug all 5 of these into the equation, get y values, plot the points, and graph it. So if I plug in negative 4 into my equation, so I do negative 4 squared plus 4 times negative 4 minus 3, I would get negative 3. If I plug in, and then if I put this on the graph, so x is negative 4, y is negative 3, my point goes right here. If I plug in negative 3, so negative 3 squared plus 4 times negative 3 minus 3, I get a negative 6. So at negative 3, I get negative 6 right here. If I plug in negative 2, so negative 2 squared plus 4 times negative 2 minus 3, I get a negative 7. So negative 2, negative 7. If I plug in negative 1 squared plus 4 times negative 1 minus 3, I get a negative 6. That point goes right here. If I plug in 0, I get a negative 3. So my parabola looks something like this. If I were to draw in my axis of symmetry, so this line at negative 2 is always a vertical line at the x value. So it would be right here, and you'll notice that this line cuts my parabola into 2 equal halves. Go ahead and pause the video and give this one a try, and then hit play and see how you did. So what you should have gotten is a y-intercept of 6, and the axis of symmetry and the x-coordinate is a negative 1. So to make the table of values, I chose the numbers between negative 3 and 1, and I got negative 9, 6, 11, 6, and negative 9 for my y values. Plot those and connect them, I get the line in red, and I have the axis of symmetry in green, showing that it cuts the graph in half. Now we're going to talk about a max or a min. So to determine whether a given parabola has a maximum or a minimum value, we look at a. So we look at this number right in front of the x squared. If a is positive, our parabola opens upward and is shaped like this picture right here, which tells us that we have a minimum point at our vertex. Okay, so if a is positive, we have a minimum. If we have a negative a value, our parabola opens downward like this graph. That tells us we have a maximum at our vertex. So negative means max. And for both of them, the max is the y coordinate of our vertex. And so once we know the x coordinate, we should be able to find the y. So we are given the equation f of x is equal to negative 4x squared plus 12x plus 18. We are supposed to figure out whether the function has a max or a min. Well, we look at a. A is a negative number. It's a negative 4. Negative means we have a maximum. Okay, we know it's a max. So then we need to find that max or min value. So we're going to find the max. So in order to do that, we need to know what the x coordinate is. So again, we do negative b over 2a. b is 12. A is a negative 4. 2 times negative 4 is negative 8. The negatives cancel each other out. I can simplify that down. My x coordinate is 3/2. So now to take that, to find my y value, I do negative 4 times 3/2 squared plus 12 times 3/2 plus 18. If I plug that into my calculator, I can get my max value, which is 27. So when they're looking for the max value, we don't write down the x, we write down the y. It's 27. So then the last thing we're going to do is we're going to state the domain and range. Domain, range. Domain for all quadratics is going to be all reals. Okay? The range is going to depend on the max or a min. If it's a max, it's going to be y is less than or equal to that max value. If it was a min, we would use greater than. So somewhere in your notes for range, if it's a max, it's y is less than or equal to our max value. If it's a min, it's y is greater than or equal to our min value. So make sure you have that written down somewhere. So now we have the equation 4x squared minus 24x plus 11. Go ahead and pause the video and answer these 3 questions, and then hit play and see how you did. So for the first question, you should have noticed that a is positive, so therefore we will have a minimum value. And that minimum value, first we need the x coordinate, so negative b over 2a. I simplify all the way that down and get 3. So then I take that 3 and I plug it in for x, so 4 times 3 squared minus 24 times 3 plus 11, I get a negative 25. Negative 25 is my min value. So my domain is all reals, just like it always will be for parabolas. My range, since it's a min, it's going to be y is greater than or equal to that negative 25.